In this video, we will discuss the segmentation capabilities with Viptela. There are many use cases for segmentation. For example, an enterprise might want to segregate traffic between different departments. They might also want to keep guest network separate from the corporate network. Another use case could be during mergers and acquisitions, where you might want to associate the newly acquired company into its own segment and then route it through a firewall before it connects to the rest of the network. Most of the time, segmentation requires that we configure it on every device in the network. However, Viptela offers a very scalable model for segmentation, which is done at the edges, and this information is carried over transport as an identifier, a model very similar to the MPLS VPN networks, but of course with much lesser complexity. Attached is the network we will use in this demo. We will be defining two different segments, one as corporate and the other as guest. Traffic between the guest and the corporate networks will be completely isolated. We will also define separate topologies for the segments. For the corporate segment, we will have the default full mesh topology. That is, every edge will form a BFD session with every other VH and route the traffic directly to its peer. The guest segment, on the other hand, will be configured as a regional hub and spoke topology. We will divide the network into three regions, and the VHs in each region would use the hub in that region as an exit point for internet as well as for communication with other regions as shown in the diagram. With that, let's begin. We will define our segments using templates. So let's go to templates. So I here have a VH Cloud template that's been assigned to my VHs. So let's go ahead and edit the template. And let's add our service VPNs to it. So let's go ahead and add our service VPN. And let's create a new template. Call this VPN 11. The ID is 11. Let's give it a name. It's a global parameter of corporate. And hit save. Let's go ahead and add an interface to this VPN. So let's create a template. Let's call this template VHVPN 11 interface template. Let's make it no shutdown. The interface that we'll be using is GE0/1. The IP address should be static, but it should be device specific. So we'll have to just change it to make it device specific, because each VH will have a different IP address for the GE0/1 interface. And this will be prompted when we update the template. So let's hit save. So let's go back to service VPN and let's add our second VPN, which would be our guest VPN. Let's call this VPN 12. Let's give it a name as guest. Let's add an interface. Create a new template. Let's call this VPN 12 interface template. Let's make it no shutdown. The interface that we'll be using will be G0/2. Again, the IP address should be static, but it should be device specific. So let's go ahead and click save. So let's look at our service VPN. And we have our VPN 11, which is corporate, and VPN 12, which is guest. Let's hit save. Here, instead of updating individually, we will use the CSV file to update the details of the service VPNs. So let's go ahead and download the CSV file. So this is the CSV file. So let's expand this. And here we'll have to update the details for the two service VPN interfaces, which is service VPN 11, which is G0/1 interface, and G0/2 interface IP addresses. So let's quickly start this. It's just 51/24. I'm just going to change the IP address for each VH. Similarly, let's go ahead and add for the G0/2 interface, which will be our guest VPN interface. So I'm just going to choose a range from 192.168.91 to 99. So let's just quickly change the IP address for each VH. That's it. We have edited the CSV file. So let's go ahead and hit save. So let's go back to vManage and upload this CSV file. Let's click upload. And there it has entered all the parameters. So let's quickly check that. So if you go to edit device template, you'll find that it has auto-populated the G0/1 and 2 interface IP addresses. So let's go ahead and hit next. Let's go and configure devices. It's just going to pop up a warning because we are trying to change 9 devices at a time. So let's go ahead and click OK. And let's wait for the configurations to get pushed. There you have, all the configurations has been successfully pushed now. So let's go to networks. Let's go to VH1. Let's go to real time and check for routes. And you can see now we have routes for both the service VPNs, and they are being learned directly from their respective peers. Similarly, let's go and check from VH9 and look at the IP routes. And you'll find a very similar thing that all the routes are being received from the respective peers for both the VPNs. Let's do a filter on VPN 12, which is the guest VPN. And here you can see that you can learn only the guest VPN subnets, and there is complete isolation between the corporate segment and the guest segment. Let's go to troubleshooting. Let's do a trace route. Let's do a trace route to 51.1. and you'll find that the traffic goes directly to that VH. Similarly, let's try another trace route on VPN 12. Let's choose 192.168.93.1. This is on VPN 12. And you'll find that the traffic goes directly as well. So let's add our policy to regionalize the guest VPN traffic. I have already predefined the policy here, but if you want to know the steps, you can look into my other videos on hierarchical or hub and spoke policy and get the details. So let's just activate the policy. The policies have been successfully pushed. So let's go back to our networks. Go to H9 real time. And let's do IP routes. And now you can see for the corporate segment, I'm receiving the routes directly from the peers, whereas for all the guest VPN traffic, I'm receiving it from the respective hub, which is .37 in this case. Let's go to troubleshooting. Let's do a trace to 51.53.1, which is on the corporate segment. And you'll find the traffic goes directly between the two segments. Similarly, let's try a destination on the guest VPN. It's 93.1 on VPN 12. And here you can see that the traffic actually goes through the respective hubs and then reaches the destination. Thus, Viptela offers a very simple and scalable way to create per VPN topology and segmentation policies. That's it for this demo, and thanks for watching.